The IK constraint is a little bit different to the others where it actually works on a chain of bones rather than just a single bone. So I've gone ahead and created a little bit of a setup here where you might see an IK chain used, and that would be a leg. So in this little mock setup, I've got my hips that are connected to the thigh bone, and the thigh bone's connected to the shin bone. We've got our target, which is our foot down here. You'll notice that I do have some brackets with some names in here. So the shin owner, this is where we're going to place our IK constraint on. The foot, this is going to be the target, and over here is going to be our pole vector. You'll see that in a moment. Another weird thing about the IK constraint is there's actually two different ways of adding this one. It has its own shortcut where none of the other constraints do. We can actually hit Shift I with our owner bone selected, and then we get this little menu here saying, do you want to add an IK constraint? You can either add it to an empty object or without targets. And this is the one I want to show you here, because this is a super weird constraint where it actually works without a target at all. You notice that it is not the default green color when we add a constraint, it is orange. And we have this dotted line that's running all the way up the chain. I'll speak about that in a moment. Another weird thing is that this constraint is actually working. However, our icon is red. It's one of the weird ones. It works without a target. But if I move this around, you see that it's kind of working, but it's affecting too much of our rig. And that's because of this dotted line, as I mentioned before. If we have a look over here, we can see our chain length. Now, when this is at 0, it's going to run all the way up the hierarchy as high as it can go. And this is not what we want, because often it'll rotate bones that we don't want to be rotated. So when we add this constraint, we always need to limit it to the length of the chain. So in this case, it is 1, 2. It should be 2 bones long. So let's click this button twice, and you'll see the dotted line runs from here to there. So let's have a look here. Now we've got this IK constraint that is working. Isn't that awesome? However, I don't think it's a good idea to use a targetless IK, because you don't really have a lot of control over how the knee, for example, is going to bend. Plus, if you reset our controls here, so let's just hit Alt-R, we have to manually reset all of our bones here. Cool. And I forgot to reset this one over here because our constraint affected it earlier. So we would have to manually reset all of our bones that are involved in this IK constraint. And that's not what we want to do in animation. It's going to make the animator's job really difficult. So I'm just going to delete this and then set it up a different way. So I'm going to select my target, and then I'm going to select my owner, who wants a constraint I do. Now we can either hit Control-Shift-C and choose inverse kinematics there, or we can use our shortcut, Shift-I, and choose active bone. All right, so let's have a look at it now. Instantly you'll notice something looks different, and that is the color of our bone. The yellow indicates an IK constraint, and it's a little bit different to the others because it works on a chain of bones, and that's what the color indicates. But if we move this around now, you'll see it's kind of working, but like earlier, it's also affecting our hips. So we need to limit the chain length, and that should be 2. So click that, and there we go. This is now working like a leg. And the beautiful thing is we have this one control, and if we reset it, the whole chain is going to jump back to its default rest state. And that's much better for animation. Now let's have a look at some of the other settings. I've never needed to disable this use tail option. It's checked on by default, which means it's going to start the constraint at the tail of the bone and then go up whatever the chain length is. But if you uncheck this, now it's going to start the constraint at the head of the bone. And that essentially just moves that whole chain one level up. And that's probably not what you want to do. I don't think you'll ever need to disable this option, so I'm glad that it's actually checked on by default. Now this stretch is also enabled by default, and when it is enabled, you would expect that we can just stretch our leg and the IK constraint would follow along. Well, that's what it does do, but we need to go to these bones and tell Blender how much you want them to stretch. So I'm going to select one of them and go over into our bone tab. And then if we scroll down into the inverse kinematics, you'll see we have this stretch value here. By default, it's on 0, which means no stretching. It doesn't need to go all the way up to 1, but let's just put it on a value of 0.1, and you can see that that bone is now stretching. However, our other one isn't, so let's do the same thing here. Let's make our stretch 0.1, and now you'll notice that both of them are stretching the same amount. If we have different values, they're going to stretch a different amount. If we have this one higher, it's going to stretch more than the other one. So most of the time, like 99.9% of the time, you want them to be the same value for the whole chain. Now, that doesn't mean it's going to stretch forever. That 0.1 value means it's going to stretch to 1. I don't know what that means, but it's going to stop once it gets to that magic number. So that is that 0.1 value. So if I raise this up, I've just selected both of them there, and then I'm just going to hold down Alt and type in 0.2. You notice it's now stretching all the way to our target. So that is how we work on the stretching there. But you'll notice that when we do stretch, the whole entire bone scales on all axes. And that's why we wouldn't use these particular bones as the deformation bones, because they would make our legs go super duper fat. So we actually have to add extra bones to kind of compensate for this, which you'll see later in the course. But this is just the basic setup for demonstration purposes. Now the weight position is enabled by default and set to 1. We also have here the rotation. So what that means is when we move this here, it's going to calculate the position at 100%. So that's how it's going to figure it out. If we disable this and choose rotation, it's actually going to just rotate our whole chain based on our target rotation. And often that's not what we want to do. So most of the time we can just leave that at the default settings. All right, so now you can see when I bend my leg here, we don't have much control over how this knee actually bends, but we can control it with a pole vector. That's why I went ahead and set up this bone. So when we go back to our constraint, you can see pole target. So we can use a secondary target to control the roll of that whole chain. It can be a different object or the same object. In our case, it's the same armature. So I'm just going to copy that and paste it in there. Now you'll see I've broken my constraint for real this time because it's asking for a bone. So we're going to click in here and then we're going to choose the pole vector. And you'll see now when we move this bone around, that's going to affect our knee. However, you'll notice that our knee is pointing in the wrong direction. And that is because the IK constraint will always point the positive X towards that target. That happens to be the side of our knee rather than the front of our knee. So there are two different ways to deal with that. One is to, when you're in edit mode, roll the bone in its default state so that the X is facing the target. So let's just rotate that one there, negative 90 degrees. And now when I jump back, you'll notice that it is pointing in the right direction. But that's not the only way that we can fix that. Another way to fix that is with this pole angle here. So we can offset that value. And I usually just drag it left or right to figure out what direction. And when I drag it left, it's moving correctly. So I know that this should be negative 90 degrees. And now my knee is pointing in the right direction. Now, the only other thing that I haven't explained is this iterations number here. This is the maximum number of solving iterations Blender will run in order to figure out how to rotate the bones so they're where you want them to be. But honestly, you'll never need to touch this setting either. 500 is more than enough, and in more than 20 years of using this, I've never had to touch it at all. So you can safely leave that one alone. And before I bring this lesson to a close, we're just going to talk about some of the common issues that you're probably going to face when you first start using this constraint. Now, the first issue you're probably going to be scratching your head about is the bone chain length, which we've already spoken about. Here, I've just added a few more bones to my setup here to show you the effect that can have. You can see that the constraint is affecting our whole entire spine here. We don't want that to happen. Our issue is the chain length is set to 0, which means it's going to run up the hierarchy as high as it can go. We should limit our constraint to the length of the chain, which in this case is 2. The next issue is with our parenting. It's important that the target of our IK constraint, in this case the foot, cannot be a child of this IK chain. If it is a child, you'll add your constraint and then you'll do this and it'll just go crazy. Now, why is that? That is because the shin is depending on the foot through the constraint and the foot is depending on the shin through parenting. So we have ourselves a dependency cycle. So we need to make sure that our target is not parented. I'm just going to hit Alt-P and clear that parent, and now it's working correctly. Another problem is with a dead straight IK chain. If this chain happens to be straight and we try and move it, Blender can't actually solve it to try and figure out which way that you want to move the bones. They're going to shrink. They're just going to do weird stuff. So you can't have a dead straight IK chain. To counteract this, we always have a slight bend in our knee or wherever the joint is in our chain. And we usually push it towards the kneecap so that our IK constraint can actually solve. So always make sure there's a bend in your chain. And the other problem that you might come across is the knee pointing in the wrong direction. Our knee is pointing this way when we should be pointing towards the target. And as I've already explained, there's two ways of fixing this. We just need to make sure that the positive X is pointing towards our knee in edit mode. So we would roll that one around, or we can change the pole angle on our constraint. And that's the two ways that we can fix that. So there we go, that's our IK constraint. Hopefully this video demystified all the intricacies of it, and now you know how to get yourself out of some problems if you happen to get yourself into them.